process more thermodynamically
Rock.
favorable. The magnitude of delta G will increase. My answer for B is consistent with my answer from A. In A, I said that delta S was positive. And so my answer for B is consistent with me saying that delta S is positive. In A, I said that delta S was negative. My answer for B is consistent with my answer for A. So if I switch this, if I put this explanation for this one, I would get B wrong. Your answer needs to be consistent with the one that came before it. What change, if any, would occur in the value of the equilibrium constant KEQ for the situation described in part B? Explain your reasoning. Now, we haven't talked about this yet, but it's time to start. Delta G naught is negative. Spontaneous. What does spontaneous mean? What does spontaneous mean? Spontaneous means that the reaction will happen in the direction that it's written preferentially. Furthermore, delta G naught equals negative RT natural log K. So there's the equation as well. Although I'm going to be honest with you, trying to figure out this equation is going to be tricky because of the natural log there. So what I'm going to do is I'm going to talk about this in terms of equilibrium. Let's go grab the reaction again. Great. A negative delta G means that it's spontaneous in the forward direction. Spontaneous in the forward direction. This means the reaction is going to favor the products. All right, getting closer. K is the concentration of products over reactants. So if we're favoring the products, you know what, I'm going to make this less confusing. I'm just going to get rid of the actual chemicals here. Let's talk about this in a general sense. If the process becomes less thermodynamically favorable, if the process becomes less favorable as T increases,
Hey.
equilibrium is favoring the reactants. So K in Q is decreasing. Right, so a negative delta G means that it's proceeding fine in the forward direction. That means that we are favoring the products. But if the reaction is becoming less negative, if it's becoming less favorable, that means we're increasingly favoring the reactants, and the reactants are on the bottom of the quotient. So if the bottom gets bigger, then the quotient gets smaller. So if we increase the amount of reactants, then the K is going to decrease. The absolute temperature at which the forward reaction becomes non-spontaneous can be predicted. Write the equation that is used to make the prediction. Why does this equation predict only an approximate value for the temperature?
Bruh.
Okay, here we go again. Delta G equals delta H minus T delta S. Solve for T.
I'll be down there for my job stacks.
process, the temperature at which this becomes non-spontaneous.
I mean, she's dead. She's dead.
Equation is right there. Delta G naught equals delta H naught minus T delta S naught. Why is this an approximation? I mentioned this the other day. You need to pay attention to the bells and whistles. You need to pay attention to the little details. Delta H naught, delta G naught, delta S naught. What does that mean? It means 298K. Standard conditions are 298K. If we're solving for temperature, the temperature had better be 298K. These values are only for 298K. If you're going to change the temperature, you're going to be changing the value. The little bells and whistles, they matter. Okay, so having the naught on there means that the temperature is necessarily at 298K. That's not negotiable. You can do this calculation, but it's not going to be accurate. If you want to do this calculation, you'll have to know the value of delta H, delta G, and delta S at the temperature that you're supposed to be finding. So you would have to measure all three of these at that temperature, but you wouldn't know what the temperature is because you're supposed to be finding that temperature. So it is necessarily an approximation. These values, delta G, delta H, delta S naught, are only good at standard conditions. So if you're not at standard conditions, you're necessarily going to get an approximation. Okay? And you can do that, you just have to recognize that it's an approximation. Okay. Let's leave the practice problems behind for a second. Let's go back to the notes. The reaction to methanols plus 3 O2s
I need butler.
yields 2 CO2 plus 4 H2O. You know, we're going to be there, so let's write down all the values. Let's write down the delta H, the delta S, and the delta G. Okay, where did we go to find this information?
I run this fucking game, bro.
We're going to need to go to the textbook. So the table in the back of the textbook has thermodynamics data, and we've been ignoring delta S. We have a delta H, we have a delta G, and we have an entropy. So what I'm going to do is I'm going to copy down all three of these for all of these guys. First, let's find methanol. I already know methanol is going to be in the carbon section. So let's go find some carbons. Oh, we just passed by oxygen. We could have
I kill this. I fucking win this right here.
I'm in such a hurry to go find methanol. That's the 2 C's. We want just 1 C. Here's methanol. Now, there's 2 states of matter for methanol. There's the liquid and there's a gas. Does the state of matter matter?